So the limit of a polynomial, okay, let's call it P of x, as x approaches a, happens to be just P of a. So already you know that I mentioned several times x approaches a, which automatically says x does not equal a. But here I am telling you to plug in a and get the limit. So the question here is what? I would like to know the behavior of this polynomial when x approaches a. So this is the polynomial, and I'm asking you plug it in and get the number. So if the polynomial is a function like this, and a is right here, all you have to do is to determine this value, just punch in a, because this is where the function is going, towards this point. Same thing with the limit of a rational function as x approaches a. It's still the rational function. I'm going to call it r of x. It's r of x, but there is an if here, which we had a few minutes ago, right? If a, this number, is in the domain of r of x. So now, keeping these in mind, I'd like to look at a couple of examples. So let's look at, I don't know, 15. I'm going to copy 15 and then I'll stop sharing. So limit as x approaches 2 from 2x to the fourth minus 3x cubed and plus 4x minus 1. I see that this is a polynomial function. Polynomial. How do I determine the limit? I would like to know when x approaches 2 from either side.
So you plug in 2 for x.
That's it. That's all I have to do. So so this is the polynomial evaluated at 2. Even if it were positive, so 2 from the right or 2 from the left, it doesn't matter. I would have determined the limit still as P of 2. So I have 2 times. I know that 2 to the fourth is 16, minus 3. I know that 2 to the third is 8, plus, and 4 times 2 is 8, and minus 1. So what do I get here? This is 32 minus 24 and plus 7. So this is 39 minus 24, which is 15. So the limit is 15. Because I identified that this is a polynomial, all I had to do is just plug it in. Now, this always happens when we are looking at a limit of a polynomial. Any questions for me, please? Any questions?
If we were doing this on homework and we got that answer 15 and we drew a box around just the number 15, would that be
yes.
Okay.
You didn't have to do this step. I know that this is calculus, so we're not doing really a lot of arithmetic here, so I'm fine with that.
I understand that. I just didn't know if we had to write out like the
no, you don't. You know, I'm fine. Okay. I'm fine if you don't write this. I agree.
Can you go up for a bit?
Say that again.
Can you go up?
Oh yes.
Thank you.
Thank you. Always stop me if you have any questions, please. That's never an interruption, ever.
All right, that's good now. Thank you.
Thank you. Okay, so this is how we calculate the limit of a polynomial. Very simple. So now let's say, let's look at a rational function like this one, number 17. And this is the same on page 124. I didn't write the page here, forgive me, it's 124. Okay, so we have a rational function, which is limit as x approaches 3 from x squared minus 8 divided by x minus 2. So we have that second theorem that says if this number is in the domain of this function, plug it in like if it's a polynomial. No headache whatsoever. And I'm going to have to do that. First, I always plug it in. Even if I know that x is not 3, I need to plug it in to see the type of limit. So when I plug it in the numerator, what do I get?
1.
Yes, because it's 9 minus 8, which is 1. When I plug it in the denominator, what do I get?
1.
1. So I don't have any headache. It's just 1. And that is the final answer. There is no need to do anything here. Now, I also need to explain something very important. We will encounter limits in which when I plug in the number 3 in the top, I get 0. And when I plug in number 3, or whatever number I get in the denominator, I get 0.
Would that mean it does not exist?
Very good question. Very good question. No. This means that there exists, or there is, hope. I'm not saying the limit exists. I'm saying there is hope that the limit might exist. This is one case. The second case is any number. I'm just going to pick 5. 5 divided by 0. This is guaranteed 100%. The limit does not exist. Absolute guarantee. But the exact answer in this case could be positive infinity, negative infinity, or DNE. Not necessarily DNE, but all of them mean DNE. But this one I cannot write DNE. For this one I cannot write DNE, only when they are going their opposite directions or different numbers. So if I have any number over 0, it's guaranteed not to exist forever and ever. If I have 0 over 0, there is no guarantee that the limit exists, but there is hope. Okay. So
I have a question.
Please do. Any.
So say there was a homework problem where it came out to 0 over 0, would
Yes.
we have to write out there is hope that the limit might exist?
No.
Okay.
Allow me to give an example. Yes. Very good question. Thank you. Okay, here's an example. Bear with me because my device is so far away from me. Okay, I'm going to look at these infinite limits, but I'm looking for something else right now. Not infinite limits. I'm looking for something like 25. And we're going to get to the infinite limits in a minute. So 25 is the limit of x to the third minus 1 over x minus 1 as x approaches 1. Okay, I want to copy one more, like 21, which is limit x squared plus 5x minus 6 over x squared minus 1 as x approaches 1. Okay, good. So I would like to start with 21, and I'll explain in a minute why I didn't want to start with 25. So we start with 21 first. Every time we're asked to determine a limit, step number 1 must always be plug it in. And you can say this is a contradiction. You already told us that x does not equal 1. Why on earth you are coming back and changing your idea? Because of this theorem. And because of this theorem. If it's a polynomial, it's the same with plugging it in, although x does not equal a. With rational, it's the same with plugging it in as long as a is in the domain. So because of these theorems, I always have to plug it in to see what it is. It could be this, I hope. It could be this, which has no hope. The limit does not exist. So I have to see what it is first. Okay, so when we plug in 1 in 21, what do we get?
1 plus 5 minus 6 over 1 minus 1.
What do we get?
0 over 0.
0 over 0. Ah, so I know what I'm facing. Potentially the limit exists. Because if it's this, I'm done. I have to identify 1 or 2 or 3. But I know it's done. But this one has hope. In other words, I have to work on it. Algebraically, I have to do something. Okay, so let's see. Is there something we can do here? And let me remind you, you may have heard of this or not. If we plug in a number in a polynomial, so this is a polynomial. So if I plug in 1 and I get 0, x minus 1 is a factor of that polynomial. Guaranteed. If I don't get 0, x minus 1 is not a factor. So if I plug in 1 in this denominator, in this polynomial, let's say r of 1 is 0, x minus 1 is a factor, guaranteed. This is the factor theorem and the remainder theorem. We don't have to spend a lot of time on that, but tell me what I should do to the top. Sorry.
Simplify, or what's it called? Factor it?
Exactly. And what do you expect to have one of these factors guaranteed?
X minus 1.
Yes. What if I
And then-
have here x approaches -2 and I get that p of -2 is 0? What is the factor? What is the factor?
Minus 2.
What is the factor? That's why I showed this. So you don't say x minus 2.
Oh, x plus 2.
Exactly. Is a factor. Exactly. Because remember, when I say to you x approaches 3, I can also say x minus 3 approaches 0. Same thing. If x approaches 3, then 3 minus 3 must approach 0. If x approaches -2, then x plus 2 must approach 0. Okay, so now let's figure out the rest here.
X plus 5 on the top.
X plus 6. Good.
Oh, that's what I meant, because when you subtract it, it's 5. I just...
Good. And the denominator? We discussed.
X plus 1.
Yes, we discussed this on the first day of classes. Oh, so look, the problem, the culprit is going away. And now, when I plug it in, it's all free and clear of the problem. So what is this limit?
7/2.
That's it. The limit is 7/2. Excellent. Can you please upload just this? I want to see that you wrote, you don't have to write this part, but I want to see that you copied the limit operator, because if you drop it before we apply the limit, then that is wrong. And I say it so many times to my students, and they still drop the limit operator and just copy 7/2. So please, I want to see that this is okay. And you will not believe, not everyone uploads correctly, in the sense that writes correctly and uploads the correct notes. Please, please work with me.
If all I have on this sheet is number 21, and
That's
actually
fine.
looks very similar
Excellent.
to your sheet, that's okay?
That's
Okay.
perfect.
I just swapped
And now I'm
papers.
going to copy this one, x cubed minus 1 over x minus 1, and you'll see why I left this for a moment. So this is 25, limit as x approaches 1, x to the third minus 1 over x minus 1. So let me wait for a second for you to upload. I got another sip of water and I'm ready. Okay, so let's discuss this one. Okay, so can anyone tell us? And notice how I write it. Please notice this, above and below, so we know how to proceed. Please do not drop the limit operator. Please, I'm begging you, till you apply the limit operator. Now, at this stage, there is no need to write the limit operator again because we applied the limit to this quantity or expression and we got 7/2. Okay, can anyone give us the top and the bottom? So please use the raised hand so everyone gets the chance to answer. So can anyone tell us the numerator and the denominator? Please. Yes, Kimmy, please.
1/1, or I'm sorry, 0/0.
Indeed. So there is hope. So I have to dig deep now. So can you tell me what is for sure a factor from the top and bottom? Guaranteed. That's it. So obviously there is something left over here. So the reason why I didn't want to start with this is because I want to refresh your memory on the difference of cubes. Anyone remembers the difference of cubes formula? So it's a minus b and a squared plus ab plus b squared. So I have the a minus b already. And of course, let me also show the other formula with the plus here and the plus here and a minus here. So minus, minus, plus, 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 minus. Okay, so this is x squared plus x plus 1. X squared plus x plus 1. What will you do next? What is the next step here, right now?
To factor down the quadratic a little bit more.
You cannot.
in that one?
Very good point. This is not factorable.
Oh, okay.
Not factorable. So what do I do? Next step, right here, right now. Yes, I'm sorry, Mallory?
You would eliminate the x minus 1s and you would be left with that.
That's
squared
what I
plus
wanted.
x.
That was my whole purpose. If I could get rid of this. And sorry, I saw Ryan and I saw Kimmy. I saw that. Okay. So that's my purpose. And now I have the limit applied to a polynomial. How do I get the limit applied to a polynomial? And please drop the limit operator now and give me the answer, please.
You plug it in.
Yes. How much? Kimmy?
3.
That's it. Done. Okay, any questions here? Are we okay so far? I would like to look at one example with a radical and the infinite limits. Okay. So let me explain the infinite limits first. So let's look at, I don't know, 33. So limit x plus 2 over 6x minus 10 as x approaches negative infinity. Okay, so here is how we address this issue. First, before we look at this problem, I would like to ask you to look at the following situation. Limit of 1 over x when x approaches infinity. So I have $1, and the number of people I want to share the dollar with goes to infinity. So 1 over infinity. I have $1 and I want to divide by 7 billion people. When I get to your door, how much will you get from that dollar? Kimmy?
0.
Absolutely 0. So keep this in mind. What if I have here x approaches negative infinity? Who cares? What is the answer?
Also 0.
Absolutely, Manny. Exactly. Absolutely 0. Good. So now keep this in mind. What is the degree of this numerator? Degree.
1.
Yes. What is the degree here?
Also 1.
Excellent. We are going to factor out the degree. You can say, but that's not factorable. I know. We'll do it by force. So x times what is x?
One.
Plus. X times what is 2? Well, it has to be 2 over x. Because x over 1 times 2 over x, these two go away and I get my 2. So x times 1 is this, and x times 2 over x is 2. Can anyone tell us what to write here? When I take x by force out. Ryan?
That'd be 6.
Yes?
And then -10, I guess, right? Over x.
That's it.
Sorry.
So x times 6 is 6x. X over 1 times 10 over x is 10. Now you allow me to simplify something?
X.
Of course. And now stay with me. 2 over x or 1 over x, same thing. As x approaches negative infinity, where will this go?
Zero.
Very good. Where will this go?
Zero.
Good. What is the limit? And now I drop the limit operator.
0.
Where does the numerator go?
1/6.
Very good.